Hi, I'm Miguel. Welcome to a new episode of TechBites. Black Mirror, a tech dystopian anthology series, is back with a 6th season. And it's just in time for the new waves of world concerns like generative AI, data breaches, crypto crashes, and such. The first episode of the season, Jonah's Awful, takes on this trend towards automation within the entertainment industry in particular. Don't worry, we are not going to spoil it, but if you have watched it, there's a glittering quantum computer that is able to transform one day of a normal person into an episode of a TV series within hours, using generative AI technology, and ruining lives along the way. Despite that, Black Mirror is not realistic. The episode has a quite solid technology background. Generating long and coherent videos within hours costs crazy amounts of computational power. Currently, we still need seconds to generate just one decent image. Quantum computer is in fact a very strong candidate in the future that could surpass our current hardware to make it happen. When we talk about the word quantum, the specific mechanism might remind you of the painful physics concepts at school. Imagine when solving a maze, classical computer mechanism is like being one person at a time, trying different paths to get out. Oppositely, the mechanism of a quantum computer is like having different clones of a person, and they explore different paths at the same time, which is what happens in the quantum bit or a qubit. In solving complicated questions, quantum computer is a way better option. A typical example from cryptography, prime factorization works as multiplying two extremely large prime numbers and receiving a large number that can only be divisible by them, to make these two prime numbers as the keys. Classical computing would take years to reversely find these two prime numbers with doing division once at a time. With quantum computing, the calculation can be done within hours due to parallel computing. However, it's still in a very early stage due to quite a few limitations. The biggest obstacle is the extreme environmental condition. The quantum bit is vulnerable with the slightest change in temperature.
Everything you see here, from the wiring to the aluminum, copper, and gold metal stages, have been chosen to create a cold and quiet environment for our quantum processors to operate.
Right. And in English?
It's a fridge for our qubits.
Right. And how cold are we talking about?
We approach near absolute zero, 10 millikelvin to be precise.
Humidity and electromagnetism such as light, radio waves, Wi-Fi, etc., and becoming prone to making mistakes in calculations. To build a viable system, we need millions of qubits, and controlling this large amount of qubits is impossible for now. On the other hand, a more promising news is that it is no longer a concept to make a quantum computer. There are several experimental prototypes. Companies like Microsoft, Google, and IBM, and many startups too, are collaborating with dozens of universities and government research institutes into researching, developing, and manufacturing early models using different qubit types. IBM is considered as a trendsetter in the field of quantum computing, having developed some of the earliest quantum computers, quantum algorithms, and being the first to offer cloud-based quantum computing access. IBM is continuing to release new versions of its quantum computing technologies and plans to release a chip with 1,000 qubits. This is going to be a great advancement as the current record is only 400 qubits, which is also made by IBM. In 2019, Google announced that they claim to have achieved quantum supremacy, which is based on a computation that is considered to take ordinary supercomputer 10,000 years to complete, but only took 200 seconds in a quantum computer. However, years later, a research group completed the calculation in several hours in a supercomputer. Instead of being embarrassed by their exaggeration, Google continues to developing their hardware. Their most recent quantum processor was published in 2021, which has 54 qubits and has less than 1% error rate. Intel recently started shipping a 12-qubit quantum processor. Although the amount of qubits seems far lagging behind from other companies, they are exploring new types of quantum, using silicon, as their current business in CPU manufacturing is also based on the silicon and semiconductors. Their competition is not only limited in hardware. Microsoft has their Azure cloud platform introducing functions that simulates the quantum processor and lets researchers developing algorithms upon that. There are also companies like Ali investing in quantum computing facilitated cloud computing services. Major players in the aerospace industry, such as Honeywell and Lockheed Martin, have also made significant progress in research and development in the field of quantum computing. Despite the long road ahead, these prototypes or proof of concept advancements are like the Wright brothers' 12-second flight. They are very basic and short-lived, but it demonstrates what is possible. From cybersecurity to pharmaceutical research, here are some ways quantum computing facilitates major advancements. Machine learning, especially deep learning and AI models, benefits a lot from parallel computing that quantum bits can provide. They both involve probability and high-dimensional calculations. That is why in Black Mirror, the generative AI is able to use the Quamputer to create an episode of TV series within hours. It may not be science fiction, but it's going to be reality in the future. Finance was one of the earliest domains to embrace big data. Still, quantum speed has long been a source of advantage in financial markets. Hedge funds now compete to get a millisecond advantage in obtaining price information. Quantum computing is definitely going to bring the competition to the next level once it's deployed. Financial institutions can use it to simulate complex financial systems and make more accurate predictions and identify risks. Chemical and biological engineering can use quantum mechanics for molecule manipulation.
Quantum chemistry is the area of computational chemistry that tries to understand how molecules react with one another, what their energies are, and how atoms move around in a chemical reaction.
Quantum computers have simulated simple chemical reactions, opening doors for complex simulations. This enables modeling challenging molecule configurations. Quantum simulations will accelerate material discovery and drug development and predicting new molecule properties. It could probably explore a new method in treating cancers and intractable diseases. However, such a powerful tool is a double-edged sword, especially in the cybersecurity field. Current encryption methods mostly rely on the belief that combinatorial calculations are unmanageable within a reasonable time frame. Quantum computing, on the other hand, poses a significant threat to encryption security. As the example we mentioned earlier, decryption time could be reduced from years to mere hours, rendering many encryption algorithms ineffective. We do have noticed the great risk that may pull down the modern cyber world, and there are researchers that develop algorithms that are resistant to quantum computing. As being a possible game-changing technology in various critical fields, quantum computing is receiving a large amount of investments from the government. The estimated amount from public sector to date is around $34 billion. Among the countries, China invests the most, with $15 billion into the research, development, and quantum-related education. While the current market size is merely estimated to be less than $1 billion, prediction from McKinsey indicates that quantum computing would grow into an industry that is worth $100 billion within 20 years. And the economic value created would be 10 sizes of that. Quantum computing is believed to have the potential to spark another revolution in various industries and civilizations at the hardware level. No one can predict how quantum computing would actually change the world profoundly. But reflecting on what's going on in Black Mirror, it could be both exciting and horrifying living in a world with technology advancements in an explosive way. Taking control of it is as important as making good use of it. Thanks for watching this episode. I'm Miguel, and see you in the next one.